Hi, in this video we're going to talk about how to find the molar solubility when given Ksp. So in the previous video we did the opposite. We're finding the Ksp when we're given the molar solubility, and that makes our job really easy because Ksp is just equal to the concentration of X product 1 times the concentration of product 2, right? And then if you have multiple moles, you just square or cube it, whatever, and that will give you the Ksp. So as long as you have solubility, you can easily find the Ksp. Now what do we do when we're given the Ksp and we need to find these molar concentrations, molar solubilities? So what do we do when we're given the Ksp and we're asked to find these molar solubilities? So let's take a look at an example. All right, what is a molar solubility of silver phosphate in water? Silver phosphate is Ag3PO4. So what is the molar solubility of this in water? And it told you that the Ksp for this is equal to 1.8 times 10 to the negative 18th. So our first step again is to write the dissociation equation. All right, PO4 is going to form 3Ag plus PO4 3 minus, and our Ksp will be equal to Ag plus cubed times PO4 3 minus. Now to calculate for the molar solubility, we're going to have to set up a rice chart, and our rice chart is going to include our original reaction, our dissociation reaction, PO4 3Ag plus PO4 3 minus. And since this is solid, we're going to not include this. And initial, all right, initial we have none. Change, what is the change? Well, in rice chart, you're going to write plus 3x and plus x, right? Because that's how much most of each should have. Except this time, now that we're calculating molar solubility, instead of x, we're going to write s, plus 3s and plus 1s. This s is going to represent solubility. So now this is going to be 3s and s. So our Ksp, let's plug this back into this reaction, right? Ksp is equal to, what's the concentration of Ag plus at equilibrium? It's going to be 3s. It's going to be 3s cubed times this over here, times 1s. So let's use our given Ksp, 1.8 times 10 to the negative 18th is equal to 3 cubed is 27. 27s cubed times s. So which is equal to 27 times s to the 4th power. All right. Now 1.8 e to the negative 18th divided by 27 and take the 4th root of it. So that will be, our s value will be 1.6061. 1.61, actually just 1.6 times 10 to the negative 5th power. And that is our molar solubility. S is equal to molar solubility. So the molar solubility indicates that 1.6 times 10 to the negative 5th moles of Ag3PO4 will dissolve in 1 liter of an aqueous solution. That is what our molar solubility tells us. Right, now let's do another problem. It says the Ksp value for silver carbonate, which is Ag2CO3. Alright, the Ksp for silver carbonate is 8.1 times 10 to the negative 12th at 25 degrees. Now what is the solubility in grams per liter? So let's create a rice chart and write Ag2CO3 forming 2Ag plus CO3 2 minus. We cross this out, 0 0 plus 2s plus 1s, 2s and s. Then we write a Ksp equation. Ksp is equal to the concentration of Ag plus squared, because we have 2 moles, times the concentration of CO3 minus, CO3 2 minus. Now Ksp is 8.1 times 10 to the negative 12 is equal to 2s squared times 1s. These values go here. And then 8.1 times 10 to the negative 12 is equal to 4s squared times s, which is 4s cubed. Alright, now we can just take 8.1 times 10 to the negative 12, 8.1 e to the negative 12 divided by 4 and take the cube root of it. Now S is equal to 1.3 times 10 to the negative 4th power. Now what is this? This is molar solubility. So this is moles. This is molar. And to convert it to moles, we're going to do 1.27 times 10 to the negative 4th moles. This is moles per liter. Over, let's see, how much grams is in 1 mole? Right, we want to keep liters because we're solving for grams per liter. The question asks, what is the Ksp in grams per liter? So we keep liters, and we're going to do moles to moles. These two are going to cancel out. So how much is in 1 mole of Ag2CO3? So Ag is, Ag is 107.87 times 2 plus carbon 12.01 plus 16 times 3. It's going to be 275.75 grams. So 1.27 e to the negative 4th times 275.75 then give you 0.035 grams per liter. So our solubility is 0.035 grams per liter. Now if it asks you what is moles per liter, if it simply asks you what is the molar solubility, then your answer will just be this. But since it asks for grams, we need to do an extra stoichiometry step to solve for grams. And that's it for this video on how to solve for the molar solubility when given Ksp. Thank you for watching.